greater quantity when there is a high coefficient wear designed. In the case of a low coefficient wear, for the same discharge, a greater depth of flow would be needed. So this is optimization on the design of the body wall of the weir to have the maximum coefficient of discharge, and at the same time to facilitate the rural labor to construct it easily. We can provide an ogee profile, but it is difficult to execute in the rural settings and difficult to maintain the profile according to ogee. Almost the same high coefficient of discharge can be obtained by this profile. Now this design has got an apron on the upstream side, a cutoff wall, and then a foundation for the body wall, and apron on the downstream side, and continuation of the concrete apron, and a downstream cutoff wall, and loose rough stone apron on the downstream side of the concrete apron. The idea of all these aprons is to see that when water overflows over the body wall, the energy of the falling water is dissipated properly, and the downstream of this structure is quite safe and will not get eroded due to the flow of water coming from the structure. The energy of the falling water is dissipated through a hydraulic jump which is caused, and that hydraulic jump should always be within this zone for various depths of flow. And once the energy of the falling water is dissipated, it's just a velocity of flow, and there will be further reduction of the velocity of flow as it travels, and as there is a wider section, and also the rough stone apron here would be able to withstand any such velocities. And it is quite safe down below for the natural stream profile to take the velocity coming from the structure. Now in this case, certain economies have been made by providing hollow blocks, by providing a sort of a reverse filter to release the uplift pressure. With these devices, we can release the uplift pressure, an engineering term which we don't have to go in great detail. If these structures are not there, reverse filters and the hollow concrete block is not provided, there will be greater uplift pressure, and to withstand the higher uplift pressure, the thickness of the apron has got to be increased. Now by providing these devices of reverse filter and hollow concrete blocks, we are reducing the uplift pressure because the pressure is released through this filter as well as the hollow block, and therefore the thickness of apron can get reduced. So these are the economies made in the design to see that the structural cost is brought to a minimum. And when we see this whole structure in the plan, it's clear. This is the body wall portion in the plan. The length depends upon the width of the stream, and it has got an abutment here, and it has got a wing and a return for suitable bank connections. So this wing and return is also there on the other side of the stream, and this has got a continuity of wing wall. In continuation of abutment, there is a continuity of wing wall up to a particular distance as shown here, and the height of wing wall should be such that there is a free board when the water passes, maximum depth of water passes here. So these are all the engineering details, and this is the engineering detail pertaining to the porous concrete block and the reverse filter. These quantities are given in ready reckoner tables given along with the guidelines. For a particular height of body wall and for a particular depth of flow, all these dimensions are given in those tables. Now, one table gives for a particular height of body wall and for a particular depth means maximum depth. What should be the width of the body wall, W? What should be this L1, L2? What should be the thickness of this apron, T2? What should be the thickness of this apron, T1? What should be the depth of the upstream cutoff wall? What should be the depth of the downstream cutoff wall? All these dimensions are given in the ready reckoner tables. Again, the quantities of work involved, for example, the quantities of concrete, quantities of masonry, quantities of wing wall masonry and the plastering, the quantities of rough stone apron, they are again given in another table and it can be costed and estimate can be prepared. So, for any check dam, any cement based check dam which is intended for the purpose of diverting the flows for irrigation purposes, the ready reckoner tables give the quantities of various items of work and also give the various dimensions of the structure. The estimate can be prepared using these tables, and with a minimum amount of training for an hour or two, the villagers themselves or the watershed committee members themselves can prepare estimates and execute work. But I am again repeating, these structures are not for recharge purposes. They are primarily for purpose of irrigation structures, and they are intended for diverting the base flows in the stream or the low flows in the stream for gravity flow and irrigating the areas on either side of the stream.